Hey there, we're about to pull back the curtain on something you and I use literally every single day, but probably never think twice about: our Wi-Fi. We're going to uncover this surprisingly deep, complex world of networking, and our guidebook for this journey? It's going to be a simple product catalog showing us the actual hardware that makes the magic happen.
Okay, let's start right here. You almost certainly have a little box like this one, blinking away quietly in some corner of your home. It's your Wi-Fi router. But have you ever really, truly stopped to wonder what it's doing? How does it take the entire internet from a single cable and just spray it through the air in your house? Well, that's where we're going to start.
So here's our roadmap. We're going to start with that familiar Wi-Fi box. Then we'll look at how you build bigger and better networks. We'll meet the unsung hero of the digital world, the switch. Then we'll see how networks think, directing traffic. And finally, we'll zoom way out to see the massive, invisible connections that tie the entire world together.
All right, part one. Let's get to know the heart of your home network a little bit better.
At its core, your router has one big job. It's a gateway. Think of it like a doorman. It creates a private, safe network just for your stuff: your phone, your laptop, your smart TV. And then it connects that exclusive little club to the huge, public party we call the internet. But, like any doorman, it can only shout so loud. Its biggest limitation is range.
And that limitation leads to a problem we have all felt. How do you escape that dreaded Wi-Fi dead zone? You know, the back bedroom where nothing ever loads? This is where we have to start building a bigger network.
For a bigger home, your first step up is mesh Wi-Fi. And the idea is brilliant. Instead of one router trying to scream across the entire house, a mesh system uses a team of smaller devices that all work together. They talk to each other, creating this single, seamless web of Wi-Fi. So you can walk from one end of the house to the other on a video call without it ever dropping. It's fantastic.
Okay, but what if you're trying to cover a whole office? Or a hotel? That's when you graduate to the professional gear: dedicated access points. You can think of these as pure, high-power radio stations just for Wi-Fi. They're designed to handle tons of people at once, and you can dot them around a building to guarantee perfect coverage everywhere.
Now, all those access points, all those computers in the office, they all need a physical connection back to the network. And that brings us to the true, unsung hero of any serious network: the switch. The best way to think about it is as the central mailroom for all your digital information.
And this is where you can really see the scale just explode. A small office, maybe they just need a little 10-port switch. But as that business grows, they might need a 28-port switch to handle all their employees. And for a huge corporate headquarters, you're talking about massive 48-port switches, connecting hundreds and hundreds of devices across an entire campus. The scale is just incredible.
Now here is where a little bit of networking magic comes into play. How do you get power to a security camera mounted on the ceiling, or an access point high up on a wall where there's no outlet? The answer is Power over Ethernet, or PoE. It's exactly what it sounds like. A single network cable carries both the data connection and the electricity to power the device. It's an absolute game changer because it means you can put network devices literally anywhere you can run a cable.
So, we've got everything physically connected, but now you have a new problem: digital traffic chaos. How do you manage it all? Well, this is where we meet the brains of the whole operation.
You see, not all switches are made equal. On one hand, you have an unmanaged switch. It's simple. You plug things in, they work. It's basically a power strip for your internet. But on the other hand, you have a managed switch. And this is a whole different beast. It's intelligent. It's like going from a simple power strip to a full-blown air traffic control center for your network.
So what does that control get you? Well, a managed network can actually think. It can prioritize traffic, saying, hey, this video conference is way more important than this huge file download, so the video call gets to go first. It can create secure, separate zones, so the accounting department's data never mixes with the marketing department's. And it can even watch for problems and warn an IT person before anyone else even knows something is wrong.
And at the very top of the food chain, you get into what are called Layer 3 switches. This is the serious pro-level gear. They have these special ports called 10G uplinks, and you can think of those uplinks as express superhighways. They're designed to take all the combined traffic from an entire floor of an office building and shoot it up to the next floor without ever causing a slowdown.
Okay, wow. We've gone from a single router in a house all the way up to a massive corporate headquarters. So for our final section, let's zoom out even further, beyond the walls of any building, and look at the truly invisible connections that power our entire world.
I mean, what about putting a network in a dusty factory, or a freezing cold warehouse, or just out on the side of a road? You can't use regular office gear. It would fail in a heartbeat. That's why they make industrial switches. These things are built like absolute tanks. They're sealed to resist dust and water, and they're designed to handle extreme temperatures and constant vibrations.
But this all leads to the biggest, most fundamental question. We've talked about all the equipment inside our homes and offices, but how does that blazing fast fiber internet get to the building to begin with?
Well, for millions of us, the answer is a technology called GPON. Now, the name sounds super technical, Gigabyte Passive Optical Network, but the concept is actually pretty straightforward. It's the standard technology that internet providers use to take one massive, powerful beam of light from their fiber optic cable and split it up to serve hundreds of different homes and businesses.
And here's how it works. At the internet provider's central office, they have a big piece of equipment called an OLT. That's the starting point. It sends the signal out. Then, at your house or your office, you have a small box called an ONU. That's the finish line. That's the device that catches the light signal and turns it back into an internet connection that your router can actually use.
So when you put it all together, home routers, mesh systems, access points, dozens of switches with PoE, intelligent networks, rugged industrial hardware, and the entire GPON fiber optic system, all of that staggering invisible complexity exists for a very simple reason: to make absolutely sure your cat video loads instantly.
It really is a hidden world, humming along just behind that little blinking light. So the next time you connect to a Wi-Fi network, take a second. What part of that huge invisible chain of technology will you think about? Thanks for joining me.